Hello everyone, in this video we are going to learn about the simultaneous equations on graphs. Well, in previous video we know how to solve a pair of simultaneous equations, both for the linear simultaneous equations and the quadratic simultaneous equations. What does the roots to a pair of simultaneous equations represent in geometry? That is the points of intersection of their graphs. Firstly, let's see the linear simultaneous equation. So for example, we have a question that is on the same axis, draw the graphs of 2x plus 3y equals to 8 and 3x minus y equals to 23 and thus solve it. Well, let's solve the simultaneous equation normally. So how do we solve? So we can write, let us see, this is equation 1, that is equation 2. From equation 2, what we get 3x equals to 23 plus y. That implies that y equals to 3x minus 23, and we substitute it into equation 1. We have 2x plus 3 times 3x minus 23 equals to 8. Then we have 2x plus 9x minus 69 equals to 8, so 11x equals to 77. So we have x equals to 7. Thus, y equals to 3 times 7 minus 23. That is minus 2. So if we don't use a graph, that is the process we need to do to solve the simultaneous equations. Well, let us see what the graph look like. We use geometry, algebra, so not the geometry, algebra to show that. So the green one is equation 1, that you can see over here, that is 2x plus 3y equals to 8, and the blue line is 3x minus y equals to 23, and we can find the intersection point over here. So we find that the point is 7 minus 2. So it is the same to our solution that x equals to 7 and y equals to minus 2. So we see that the intersection point of two lines is the root of the simultaneous equations. Now let us see the quadratic simultaneous equations. So similar question, that you need to draw the graphs of 2x plus y equals to 3 and y equals to x squared minus 3x plus 1. Also, we can try to solve it normally. So that is 2x, let's see, this one is equation 1, this one is equation 2. From equation 1, what we can get y equals to 3 minus 2x. And we substitute it into the equation 2. What we have 3 plus 2x equals to x squared minus 3x plus 1. And then we'll rearrange that. We have x squared minus 3x plus 2x plus 1 minus 3 equals to 0. And we simplify it. We have x squared minus x minus 2 equals to 0. So x minus 2 times x plus 1 equals to 0. This we have x minus 2 equals 0, or x plus 1 equals to 0. X equals to 2, or x equals to minus 2. In this case, when x equals to 2, y equals to 3 minus 2 times 2, that equals to minus 1. And when x equals to -1, y equals to 3 minus 2 times -1, that is 5. So we have two set of solution. That is, the first one is x equals to -1, y, that is x equals to 2, y equals to -1. Another one is x equals to -1 and y equals to 5. Then we can see in the algebra, we use that to draw the graph. We have the right line, that is 2x plus y equals to 3. And we also have the quadratic equation, that is y equals to x squared minus 3x plus 1, that in the orange line. And we can see there are two intersection points. For this one, this is 2 minus 1. And another one is 5 minus 1. Is it same to our answer? Sorry, not 5 minus 1. Wrong here. That is -1, 5. It is same to our answer. We can see that they are the same, so we have see that the intersection point is the solution of the simultaneous equation. Well, in the exam, if the question asks you to draw the graphs of that, you need to sketch it, because you can't use the algebra to do in the exam. I use that to show that the intersection point is the roots of the equations to be more clearly, so you can understand that. Well, the graph of a linear equation and the graph of a quadratic equation can either intersect in three situations. So the first one is it can intersect twice. And also can intersect once, or maybe not intersect. Well, how can we show that? How can we prove? How can we determine how many times the graphs intersect? So we can use the substitution. By using the substitution, you will get a new quadratic equation in one unknown, that is in the form of ax squared plus bx plus c equals to 0. And we have learned that discriminant of the quadratic equation can determine how many roots the equation has. Well, so if b squared minus 4ac greater than 0, so it intersects twice, the graph will look like such as kind of this, or maybe kind of this. So they have two intersection points. Well, if b squared minus 4ac equals to 0, so it intersects once, the graph will look like the line only touched once. Oh, sorry. Or maybe look like that. So also once. And we can also have b squared minus 4ac less than 0. So two graphs do not intersect to each other. The graph will look like kind of, maybe like kind of this, or maybe look like that. Now let's move on to the question. So here's a question that's given the simultaneous equations 4x minus y equals to 2 and x squared plus 2ky plus 6k equals to 0, where k is a non-zero constant. The first question said that you need to show that x squared plus 8kx plus 2k equals to 0. So in here, we need to use the substitution to get a new quadratic function that only left x, so only one unknown. So we write 4x minus y equals 2. We said that is equation 1, and another one is equation 2. From equation 1, we can have y equals to 4x minus 2, and we substitute it into the equation 2. We have x squared plus 2k times 4x minus 2 plus 6k equals to 0. And we simplify it. We have x squared plus 8kx minus 4k plus 6k equals 0. Then we have x squared plus 8kx plus 2k equals 0. So we have done that. Now move on to the second part. So given that the x squared plus 8kx plus 2k equals 0 has equal roots, so you need to find the value of k. We notice that this is a equation that is reformed. This is a new quadratic equation, and it has equal roots, which means b squared minus 4ac equals to 0. So firstly, we need to determine a, b, and c in this new quadratic equation. So a equals to 1, b equals to 8k, c equals to 2k. Then we substitute them into the b squared minus 4ac equals to 0. So we got 8k squared of that minus 4 times 1 times 2k equals to 0. Then we have 64k squared minus 8k equals to 0. And we can take 8k out of the bracket so that 8k times 8k minus 1 equals to 0. Then we can have 8k equals to 0 or 8k minus 1 equals to 0. So k equals to 0 or 8k equals 1, k equals to 1 over 8. But in the question, it said that k is a non-zero constant. So k does not equal to 0. We only left that k equals to 1 over 8. So that is the question. That is the answer. Well, let's move on to the part C. The question said for this value of k, find the solution of the simultaneous equations. So this value of k is an answer from the previous one. So we have k equals to 1 over 8. And you need to find the solution of simultaneous equations. And don't forget that x squared plus 8k x plus 2k equals 0 is a new quadratic equation. It is not the original one. So what we need to do, we need to find the value of x first from the new quadratic equation. We have x squared plus 8kx plus 2k equals to 0. And we substitute k equals to 1 over 8 into this equation. What do we have? We have x squared plus 8 times 1 over 8 times x plus 2 times 1 over 8 equals to 0. And we rearrange that. We can have x squared plus x plus 1 over 4 equals to 0. And simplify it, we have got that x plus 1 over 2 square root of that equals to 0. So x equals to x equals to minus half. That is the solution of x, and you need to find the solution of the simultaneous equation. Don't forget to get the value of y. So we have from the question part A, we get that y equals to 4x minus 2. So y equals to 4x minus 2, and we substitute x into this expression. We have 4 times minus half minus 2. What we get minus 4. So the solution of that is x equals to minus half, and y equals to -4. That is the answer. The whole process of that. So here is a conclusion for this lesson. What we learned that the roots to a pair of simultaneous equations is the points of intersection of their graphs. So when the question give you the graphs of the two equations, you can just find the intersection points, that is the roots of the simultaneous equations. And when you see the quadratic simultaneous equations, we know that there are three situations. They can intersect twice, they can intersect once, or they do not intersect. So how do we determine how many times do they intersect? You can use the substitution to get a new quadratic equation. Ax squared plus bx plus c equals to 0. There is only one unknown. And then you can use the discriminant to find how many roots there are. And here are the graphs for the different situations. You can pause the video to make some notes. Thank you for your watching.